But there's another case in which you'll be able to use the point-slope form, and that is if you are provided with 2 points on that line instead of the point and the slope itself. So in this case, if 2 points from the line are provided but not the slope, use the points to calculate the slope and then use the point-slope form. So you'll use these 2 points to calculate the slope of this line. So you'll have m, and then you can use the first point in the point-slope form with the slope to figure out the equation of the line, or you can use the second point with the slope that you found in the point-slope form to calculate the equation of the line. Let's walk through an example of this. What is the equation of the line that passes through the points 3, -1, and 0, 5? So again, we're going to use the 2 points provided to calculate the slope, and then we'll use that slope with this point or this point to figure out the equation of the line. Now step 1, subtract the second y-coordinate from the first y-coordinate. In step 2, subtract the second x-coordinate from the first x-coordinate. This is the second coordinate provided. So subtracting this from this would give you -1 minus 5, which is -6. But you can also use this point first and this point second. So you can also do 5 minus -1 in our numerator to get your delta y. You'll get -6 in the first example and +6 in this one. But once you find delta x, in this one, since you subtracted the second point from the first, in the denominator, you subtract the second point from the first as well. So you get 3 minus 0, which gives you 3. In this one, we subtracted the first point from the second point. So we do the same thing in the denominator. We do 0 minus 3 instead, which gives us -3. So our negative is in the numerator up here, but it's in the denominator down here. So for step 3, when we divide delta y by delta x, -6 divided by 3 is the same as 6 divided by -3. So after step 3, we wind up with -2 for our slope in both examples. So I wanted you to see that your final slope will be the same regardless of if you subtract this point from this one or if you subtract this point from this one. The most important thing is whatever the first one is, so this is your y-coordinate from here. So in the denominator, your x-coordinate from the same point has to go first. This one is second, so this one has to go second as well. Down here, this one is first. So this x-coordinate's first. This one's last. So this one's last. As long as you keep your x and y's together and they go in the same order, you'll wind up with the same slope. We wind up with a slope of -2. Now we use this slope -2 with either the first point or the second point in the point slope form, and then we'll have the equation of the line. Regardless of which point we use, we'll wind up with the same equation, as you'll see here. So let's say we're using the first point. Step 4, replace x1 and y1 with 3 and -1. And then step 5, replace m with -2. So now we want to get y isolated on the left side. So we want to distribute this 2 to each term on the right, and then move this constant over to this side. So step 6, distribute the -2 to the x and to the -3. -2 times x is -2x. -2 times -3 is +6. So after we distribute the -2, y minus -1 is y plus 1 is equal to -2x plus 6. And to isolate y, step 7, we subtract 1 from both sides, giving us y is equal to -2x. 6 minus 1 is 5. So we wind up with the equation y is equal to -2x plus 5. This is when we use the first point. We can plug in the second point with the same slope, and we'll still wind up with -2x plus 5. So if we go back to step 4, now we'll use y2 or x2. You can plug in 0 here or 5 here. Now I'm showing you both. If you were asked this question, you would do one or the other. Unless your instructor tells you to do both, you could use the first point or the second point and you'll still wind up with negative 2x plus 5. So here's step 4. We plug in 0 for x2 and 5 for y2. And then we plug in negative 2 for slope for our m. And now step 6, we distribute the negative 2 to each term. Negative 2 times 0 is just 0. So we just need to distribute the negative 2 to the x. So we wind up with y minus 5 is equal to negative 2x. And now step 7, we add 5 to both sides. So we get y is equal to negative 2x plus 5, which is the same equation that we got when we used the first point. So again, in this case, to use the point slope form, use the 2 points given to calculate the slope, m, and then use either the first point or the second point in the point slope form with the slope that you find to get the equation of the line. Let's have you do a few practice questions. Question number 1. What is the equation of the line that passes through negative 1, negative 4, and 2, 5? Question number 2. What is the equation of the line that passes through 0, 4, and 2, negative 6? And question number 3. What is the equation of the line that passes through negative 2, negative 1, and 3, 9? Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We are given the points negative 1, negative 4, and 2, 5. Step 1, subtract the second y-coordinate from the first y-coordinate. So if you subtract this point from this point, you'll get negative 4 minus 5, which is negative 9. If you subtract this one from this one, you'll get 5 minus negative 4, which gives you positive 9 in the numerator, which is our change in y. Step 2, subtract the second x-coordinate from the first x-coordinate. So if you subtracted this point from this point, right, negative 4 minus 5, then in the denominator, you have to use this x-coordinate first. So it'd be negative 1 minus 2. Negative 1 minus 2 would give you negative 3 in the denominator, your change in x. Here, we did 5 minus negative 4. So in the denominator, this one goes first. We have 2 minus negative 1. 2 minus negative 1 becomes 2 plus 1, which gives you 3. So step 3, divide the delta y by the delta x. The delta y is the numerator, delta x is the denominator. So when you divide negative 9 by negative 3, you'll get positive 3. 9 divided by 3 is positive 3. So we see that our slope is equal to positive 3. Now we'll use this slope of positive 3 with either the first point or the second point in the point slope form to calculate the equation of the line. So if we're using the first point, step 4, replace x1 and y1 with negative 1 and negative 4. Y minus negative 4. X minus negative 1 is x plus 1. Replace m with our slope of 3. And now we want to distribute this 3 to x and 1. 3 times x is 3x. 3 times positive 1 is 3. So we wind up with y minus negative 4, which is y plus 4, is equal to 3x plus 3. And to isolate y on one side of our equation, we want to get rid of this positive 4. So we subtract 4 from both sides. 3 minus 4 is negative 1. So we wind up with the equation of y is equal to 3x minus 1. So this is if you use the first point, -1, -4. You could have also used the second point, 2, 5. So if you replace x2 with 2 and y2 with 5, and then you replace the slope with 3, and now step 6, you want to distribute this 3 to the x and -2. 3 times x is 3x. 3 times -2 is -6. So we wind up with y minus 5 is equal to 3x minus 6. We want to isolate y on the left side of our equation. So we'll add 5 to get rid of this -5. That leaves you with y is equal to 3x minus 6 plus 5 is minus 1. So again, we wind up with the same equation when we use the second point. Y is equal to 3x minus 1. Let's take a look at question number 2. We were given the points 0, 4, and 2, -6. So we were going to use the 2 points to calculate the slope of the line. So step 1, subtract the second y coordinate from the first y coordinate. In this top example, we'll do this point minus this point. In the bottom example, it's if you did this point minus this point. So for our delta y's, you'll get 4 minus -6, which is positive 10. Or you would have gotten -6 minus 4, which is -10. In the denominator, this point minus this point, you get 0 minus 2, which is -2. Or if you did this point minus this point, you got 2 minus 0, which is positive 2. For step 3, when you divide delta y by delta x, 10 divided by -2 is -5. -10 divided by 2 is also -5. So we see our slope for this line is equal to -5. We'll then use this slope in either one of these points in the point slope form to figure out the equation of this line. So we can use 0, 4, or we can use 2, -6. To use the first point, step 4, replace x1 and y1 with 0 and 4. Step 5, replace m with -5, our slope. And now we'll want to distribute this -5 to each of these terms. -5 times 0 is just 0, so we won't need to do that. So when we distribute the -5, we wind up with -5 times x, which is -5x. And now to isolate y, we want to add 4 to both sides. So when we add 4 to both sides, we get the equation y is equal to -5x plus 4. If you use the second point instead of the first point, you'll also get this same equation. So if you replaced x2 and y2 with 2 and -6, you would have gotten y minus -6 is equal to m times x minus 2. You replace m with the slope of -5. And now you'll want to distribute this -5 to the x and the -2. So that's step 6. -5 times x is -5x. -5 times -2 is positive 10. So we wind up with y minus -6, which becomes y plus 6, is equal to -5x plus 10. We want to subtract 6 from both sides to get rid of this positive 6. So we wind up with y is equal to -5x plus 4. In question number 3, we were given the points -2, -1, and 3, 9. Again, this top calculation is if you did this point minus this point. This bottom calculation is if you did this point minus this point. So step 1, subtract the second y coordinate from the first y coordinate. So -1 minus 9 would give you -10. Or 9 minus -1 would give you positive 10. Step 2, subtract the second x coordinate from the first x coordinate. Negative 2 minus 3 would give you negative 5 for your delta x in this first example. Or 3 minus negative 2 would be 3 plus 2, which is positive 5. Step 3, divide delta y by delta x. Negative 10 divided by negative 5 is positive 2. Positive 10 divided by positive 5 is positive 2. So our slope is positive 2. Now we take that slope and combine it with either the first point provided or the second point provided in the point slope form to figure out the equation of the line. So step 4, replace x1 and y1 with negative 2 and negative 1. And then step 5, replace m with positive 2. Now distribute this 2 to each of these terms for step 6. 2 times x is 2x. 2 times positive 2 is positive 4. So we wind up with y minus negative 1, which is y plus 1, is equal to 2x plus 4. Step 7, subtract 1 from both sides to get rid of this 1, leaving us with y is equal to 2x plus 4 minus 1, which is 3. So the equation of the line that passes through those 2 points is y is equal to 2x plus 3. Let's say you use the second point. You replace x2 and y2 with 3 and 9. And then step 5 would have been to replace the slope with positive 2. Step 6, distribute this 2 to each term inside the parentheses here. 2 times x is 2x. 2 times negative 3 is negative 6. So we wind up with y minus 9 is equal to 2x minus 6. To isolate y on the left side, we'll need to add 9 to both sides, which gives us y is equal to 2x. Negative 6 plus 9 is positive 3. So again, we wind up with the same equation. Y is equal to 2x plus 3.